Alright guys, so in this problem what we have to do is we have to solve for the width of the metal strip, which in this case is the distance from point C all the way up to point D, so that's this distance over here. And the way that we're going to do that, well, there's not one specific way, one specific method that you can use on this, but the point is, you know, as long as you're consistent, you apply the right equations and concepts, you are going to get the same result. This is what I would personally do. Let's just zoom in on this real quick. So you've got this figure, and you can see that at the top, these two symbols mean that the two lines are parallel. Okay, meaning that you have to remember a few concepts from geometry. You know, these two lines are parallel, and then you have the line AB, which acts as a transversal, and AD and AC, each one of those lines are acting as transversals. So if this angle is 30 degrees, and the fact that this line is parallel to this, what that in turn means is that this angle over here has to be 30 degrees. And if this one is 38 degrees, then it means that, let's just erase these markings real quick. It means that this has to be 38 degrees. Alright guys, you might be looking at this and you're like, well, why exactly do I need to know this info? Well, the thing is, you know, once you can identify these angles and stuff, it can actually help you out a lot. What we're going to do is to find the angle, or find the width of the line segment CD, or the metal strip, what we're going to do is we're going to need to find the distance from point A up to point C. And once we find that distance, we're going to find the distance from point A all the way up to point D. So basically we're going to be finding the size of that triangle ACD. Okay, so this is how we're going to do it. Let's erase a few of these highlighting points that we have up there. Alright guys, so you got this triangle, and the first thing that we're going to need to do is solve for this distance AC. Now, I don't personally like to use the same variables that they were using and stuff, because, you know, I like to be comfortable with the problem that I'm solving with. So what we're going to do is we're going to redraw a triangle ABC. So this is your triangle ABC. We're going to redraw this thing out on the paper, and we're going to zoom in on this. So this is what the problem looks like so far. So you've got this triangle, you know that this is equal to 110 degrees. This side length is given as 200 millimeters. And keep in mind, guys, units are really important. And this angle is given as 38 degrees. Alright guys, so why is this important? Well, if you look at it, you know, compare this triangle to what you have in the original figure, you know that this distance is the same as that right there. Okay, so this is what we're solving for initially. We're going to be solving for this. So how do you actually do that? Well, you can see that you're given one of the angles, and then you're also given the distance that goes across from that angle. And the distance that you're solving for, so let's just call this x for now. The distance that you're solving for, you don't know that since you have to solve for it, but the thing is, you know the angle that goes with that, which in this case is 110. So this is a good example where you can use the law of cosines, or law of sines, I'm sorry, to get the distance x in this problem. This is what we're going to do. Since we're solving for x, we're going to say that you have this proportion that says x over sine of x, you know, and this thing represents the side, this thing represents the angle, is equal to the distance of the other side, which in this case is 200, over the angle that's given with that, which is sine of 38 degrees. Okay, and if I were to actually write this equation out, you know, let's actually select this thing. I'm going to move this down a little bit. You know, this is what the law of sine says. It relates a side over sine of its angle to another side on that same triangle to the sine of that specific angle. But the thing is, since we're calling x to be one of the sides, and we're saying that 200 is the other side that we're using, this is what the problem looks like. As a matter of fact, we can actually go back and call this angle x to be 110 degrees, because that's actually given to you. So you can see that the angle that goes with side x is 110 degrees, so you can actually write it like this. Now, what do you notice about this problem? At this point, that's one equation, one unknown, so you can actually solve for this. You just have to be careful with the fact that the problem is given in degrees, so you want to make sure that the calculator itself is also set in degrees, and the way you do that on a TI-83 and TI-84 is by going in the settings, which is really easy. You know, click on the mode next to the second key, and you can see it's already in degrees. The degrees is highlighted. So second quit. Let's go on the main screen. What you want to do is at this point, this is what I would do. Simplify this. So that's going to give you sine of 110. So once you put that in the calculator, close that parentheses, press the enter key, and let's round that to 3 decimal places. So that's going to be 0.940. And that's equal to 200 over sine of 38. Okay, again, close that parentheses, which is not really necessary, but it's just a habit, so I always do it. And again, round that to 3 decimal places, and that's going to give you 0.616. Alright guys, at this point, the way that you're going to solve for x, you're going to need to cross multiply. So we're going to take the x and we're going to multiply that with 0.616. And that's going to be equal to 200 times 0.940. So let's actually write the left hand side of that equation out. 200 times 0.940. Press the enter key and you get 188 on this. Alright guys, once you get this, what we're going to do is we're going to divide both sides of the equation by 0.616 so that this thing cancels out, and x is equal to 188 is already in the answer. So 0.616, hit the division key, divide by 0.616, and that's going to give you 305.195 if you round that to 3 decimal places. And since the original answer was given in millimeters, we're going to write this out. Again, this is not the final answer, but the thing is it's important to find this out since we're solving it by finding the 2 sides of the second triangle, which is ACD. Alright guys, so what do you do with this length? Well, the thing is, you're given this, you found this distance, which is 305.195, and what this thing represents is, let's just zoom in on this. This thing represents that distance. Okay, so that's the 305.195 millimeters. What we're going to do is we're going to need to find what this distance is. So distance AD, we're going to need to solve for this. And then at that point, we can apply the law of cosines to get the final answer, which will give you the MetalStrip. But before you apply the law of cosines, you need to find that distance AD. So how do we do that? Well, we're going to need to go back to this and take a look at the triangle and ask ourselves what it is that we know and what it is that we need to solve for. So let's actually draw this triangle out. So we're looking at triangle ABD in this case. Alright, so we're going to draw this thing out. Alright guys, again, that's what they're calling the triangle ABD. So you know that this is 110 degrees, that's given in the problem itself. You also know that the side length AB has a measurement of 200 millimeters, so we're going to write this thing out. And what you're solving for is the distance from point A to point D. Since I already called the distance on the other triangle X, we're not going to call it X, we're going to call it something else. Again, it's really up to you. But you can look at the triangle and see that since they're calling it B, we can actually just stick with that. So we can say that this is equal to lowercase b, since the angle is represented using a capital letter. You also know that the angle on this triangle is equal to 30 degrees. Okay, that's again from the original problem. So let me just zoom out on this so you guys can actually see that. Alright guys, so how do you actually start this? Well, since we're solving for this distance, we can again use the law of sines on this, which says that, you know, let's set this proportion of b over sine of b is equal to lowercase d over sine of d. Again, the variables are really up to whatever you want to call them, but since that's what they're calling, we'll just stick with that. Since we're solving for lowercase b, we're not going to plug anything in for that. Sine of capital B is 110 degrees, and that's equal to lowercase d, which is obviously the one that's across from the angle, and in this case happens to be 200 millimeters over sine of the angle, which is 30 degrees. Alright guys, at this point again, just like with the last problem, you know, the last part of the problem, what we're going to do is solve for sine of 110, solve for sine of 30, cross multiply, get the answer for the b. Alright guys, so sine of 110, put that in the calculator. And this gives us 0.940 after you round that off. And that's equal to 200 over sine of 30, which I know from memory that's 0.5. You can also refer to the unit circle on that. And sine of 30 degrees is 0.5. Okay guys, at this point you can cross multiply this. So this would give you 0.5b, and that's equal to 200 times 0.940, close that parentheses. Let's write the left side of the equation and multiply the rest of this, so that would be 200 times 0.940. Press enter and you end up getting 188 on this. Okay, divide both sides of the equation by 0.5 and that's going to give you 376. Again, this is in millimeters. Now listen guys, again, that's not the final answer, but what does that answer represent? 376 millimeters. What this tells you is, again, we're going to zoom in on this. Okay, we're going to erase a few of these things. What this tells you is that this is the answer that you got for that side, so 376 millimeters. Now we're going to focus on this triangle, the one that's on the outside. Okay, so this is the triangle that we're going to be looking at. Let's actually highlight this one. So we're looking at this triangle. Okay, we're focusing on this. We got the two sides, we got the 305.195 millimeters, and then we just found out the second side, which is 376 millimeters. Now, if you notice something, this angle at the top is given as 38 degrees, and the other angle is given as 30 degrees. So this angle has to be a difference of 38 minus 30 degrees, and which makes this thing an 8-degree angle. So what we're going to do is focus on triangle ACD. We're going to look at that knowing that the two sides are found and then the angle is 8 degrees, and we're going to apply the law of cosines on this to get the length of the metal strip, which is CD in this case. So let's just go ahead and draw this triangle out on the side, because I know that that's a lot of numbers that you see up there. Alright guys, so we're going to zoom out on this, scroll down just a little bit. Okay, we're going to draw that triangle out. Okay, so this is what the problem looks like so far. Alright, let's go back to that, see what the measurements are. So you know that the angle is 8 degrees on this. I know that this side of the triangle came out to 376 millimeters, and the other side, the left hand side, came out to 305.195 millimeters. And we're solving for the strip, which is C, the metal strip in this case, and I know that the top is equal to A. Alright guys, so what can we do on this? There's actually several different ways you can do that. You can apply the law of cosines, you can apply the law of sines, you know, there's so many different ways you can do that. But even though initially in this video I said that you can apply the law of cosines, now that I'm looking at it as I drew this thing out again, it's actually a lot easier if you just apply the law of sines on this. So since we know the angles of the triangle, we know that this thing is 30 degrees, which means that the angle at this point is 30 degrees, since we're just redrawing that triangle out. Okay, and if you wanted to find the remaining length, you could have also done that and stuff. But this is what we're going to do. Since we're looking at angle A, and we're going to need to solve for side A, we know that this thing is the side A that we're looking at. We know that this is equal to side C, and this is the angle C. And we know that this is equal to side D, and that's the angle D in this case. So it's really up to you however you want to set the proportion up, but I always like to write the thing that we're missing at the top. So since we're solving for side A, which is really the metal strip, that's the width of the metal strip, that's this distance right here, we're going to say that A over sine of A, which in this case is 8 degrees, is equal to, since I already know that this angle is 38 degrees and I know the side that goes with that, I'm just going to go ahead and use that. So this is equal to 305.195 over the sine of 30 degrees. Alright guys, let's go ahead and put that in the calculator. So sine of 8, again, we've already checked to see that this is in degrees, so we don't need to change those settings in the calculator on for now. Sine of 8, that's going to give me 0.139. Okay, that's round to 3 decimal places. And that's going to be equal to 305.195 over 0.5. Now at this point you have this proportion, we're going to need to cross multiply, so we're going to take the A and multiply that with the 0.5, and that's going to give us 0.5A, which is equal to 305.195 times it by 0.139. Press the enter key and you get 42.422. Divide both sides by 0.5 and this thing cancels. So this tells you that A comes out to 42.422 divided by 0.5, and that's going to give me 84.844 millimeters. And that's the final answer. Now again, look, we're using different variables. We're saying that that's lowercase a, but that's really the length of CD. So you can say that the line segment CD or the metal strip has a distance or a width of 84.844 millimeters. Alright guys, that's the end of the problem.